All right, what are we going to do here? Well, if we look on our right side, we have again a difference of squares. So that's really x plus 1, x minus 1. Here we have x minus 1, here we have x plus 1. So we're going to have to multiply this first rational expression by x plus 1 over x plus 1. So that would give us 6 times x plus 1 over x plus 1, x minus 1 plus 2 times, well, now we have to multiply by x minus 1 over x minus 1 to get to the right common denominator. And then that's equal to what? Well, that's equal to a minus 4 over x plus 1, x minus 1. Okay, so now we have to simplify our two rational expressions on the left, set that equal to the negative 4 on the right, and then we should be good to go. So that's going to give us what? 6x plus 6. Then we have plus 2x minus 2. That's all over x plus 1, x minus 1. And that's equal to a minus 4 over x plus 1, x minus 1. Okay. So now we have 6x plus 2x. So that's going to, let's go up here. That's going to be 8x. 6 minus 2 is going to be 4. And then that's all over x plus 1, x minus 1 equals a minus 4 over x plus 1, x minus 1. All right, so common denominator, so we can set the numerators equal. So 8x plus 4 equals a negative 4. And so let's subtract 4, and 8x equals a minus 8. Divide by our negative 8. So x equals a negative 1. Okay, so now let's see if negative 1 works. Negative 1 minus 1. Okay, that'll work. That'd be a minus 2. Minus 1 plus 1, that gives us 0. So that means it doesn't work because and if we plug in a minus 1 squared, that's going to be 1 minus 1. It doesn't work here either. And so there's going to be no solution. Okay. So again, sometimes you're going to get a solution that looks like you have a solution, but then when you do your check, and the key here is you have to do your check to know if it's going to work or not, we find out there's actually no solution to this example. All right, what about here? Well, it looks like probably we're going to have to factor each of the denominators to make it simplified. So this one is going to give us what? Well, it's going to be r, and we need a bigger negative, so it's going to be r minus 7 and r plus 6, because 7 times 6 is 42. Here, if we factor out an r, we have r minus 7. Here, if we factor out an r, we have r plus 6. So our LCD, if we write that up here, it's going to be what? Well, we're going to have an r. We're going to have r minus 7. We're going to have an r plus 6 because we have r here only once. We have r minus 7 here, r minus 7 here only once, and r plus 6 and an r plus 6 only once. And so that would be our LCD. Okay. So now we have to get all of them to have the same denominator. So if we do that, what do we have to multiply this one by? Well, we're going to have to multiply by r here. So if we do that, we have to do r in the numerator. So that'd be r over r times r minus 7, r plus 6, plus, now here we have r minus 7, so I have to multiply the numerator by r plus 6 and our denominator by r plus 6 as well. And that's equal to what? Well, here we have to multiply by r minus 7, so it's going to be r minus 7 over r times r minus 7, r plus 6. Okay, so now we've got all of them with the same denominator, so now we just have to simplify. Key thing is we have to distribute here, and so let's say we have r plus, now we have 7r, and then plus 42 all over r times r minus 7, r plus 6, and that's equal to r minus 7 over r times r minus 7, r plus 6. Now, since we have common denominators, we can just set all the numerators equal as they're written. But where I'm going to rewrite it is 7r plus r, so that's going to give me what? 8r plus 42 equals r minus 7. Okay, so if I subtract r, subtract 42, subtract 42, what do I get? 8r minus r is going to be 7r. Those cancel, those cancel. That's equal to, and it's going to be a minus 49 divided by 7, divided by 7. R is equal to, well, 7 goes into here 7 times, so we're going to get a negative 7 as our solution if it works. So now what we have to do is we have to plug that into each one of these expressions. And I think probably the easiest way is plug it back into the factored ones. It's going to be a little easier. So here we have a minus 7, so that's going to be a what? A minus 14. And then we have times, here we have a minus 7 plus 6, so that's going to be a minus 1. And here we have a minus 7 times, here we have a minus 14. Here we have a minus 7 times a minus 1. Okay. So simplifying, here we have what? A 14. Here we have what? A 98. And here we have a 7. Okay. So let's rewrite this down here. So we have 1 over 14 plus we had what, 7 over 98. Well, actually, let's check that and not do that, because if we take that 7 and cancel that 7, we just have a plus 14. So that's going to be a little easier. So that's going to be 1 over 14. And then that equals, and then we have what, 1 over 7. So now 2 over 14 equals 1 over 7. Well, if we reduce that, we get 1 over 7, so it works. And so that is our solution. So sometimes, like I did here, I was going to make it a little harder and I was going to have to get a common denominator, but I noticed that I could cancel those and then I just get the 1 over 14. And so then I could add that plus that and get 2 over 14. That reduces to 1 over 7, which is what we had on our right-hand side. All right, so again, you could have done all of the check in your calculator as well to make sure it works, and that would be fine as well. But this shows it on paper, and so like on a test or something, that's how you would probably have to show your work, is to do all this extra work. All right, let's stop there, and we'll come back for some more.